Enthusiastic enough. Let's try that again. Some of you may have been out a little late last night. So good morning, everyone. There we go. Awesome. Great. Well, thanks for coming out, everyone. It's great to see so many folks. Even in a large room like this, it's nice to see that even though there's empty seats, there's not too many. So it's a great crowd this morning. Great to see you. For those of you who don't know me, my name is Scott Schnall. I'm a principal technical writer on the Exchange team. Among other things, I write the product documentation for high availability, site resilience, disaster recovery. I do some virtualization and storage stuff as well. And I'm super excited to be here at another TechEd in North America talking about high availability and site resilience in Exchange 2013. Just out of curiosity, how many of you are running 2013 yet? Excellent. How many of you are running 2010? Wow, fantastic. 2007? Great. 2003? Yeah, everyone looks around to see whose hands are up now still. Yeah, okay. It's that guy. All right, well, the agenda is pretty straightforward. Even though the title of this session is High Availability and Site Resilience, we will also be talking about some of these storage-related innovations that we've introduced in 2013 around high availability and fault tolerance and things like that. And it's a pretty simple, straightforward agenda. We'll go through the storage stuff first, then we'll talk about HA-related things, and then we'll get into site resilience. And at the end of this session, I've got a couple announcements for you as well that you may hopefully find interesting. So let's take the curtains back off and have a look at what's behind the storage curtain, shall we? All right, thank you, PowerPoint 2013. All right, so in the case of storage, one of the things you want to keep in mind is as I talk about these innovations and I talk about the challenges that these innovations are designed to address, keep in mind that largely most of the innovations that we've made are targeted towards JBOD environments. If you're not familiar with that acronym, JBOD, it means just a bunch of disks. You're running without RAID. But having said that, anything that we're going to talk about today in terms of the storage is supported on all forms of storage that we support. So you can do this stuff in a RAID environment or in a SAN environment and so forth. But you want to be aware that it is specifically targeted towards JBOD environments because that is, of course, what we run inside of our service, Office 365 and Live at EDU and the other ones and so forth. And so as we are running this service, we're looking for opportunities to increase innovation and reduce our costs at the same time. And where applicable, we take those innovations and we put them into the product for on-premises customers to enjoy the benefits as well. So in terms of storage, when you think of some of the challenges that we face, well, one of the challenges is being faced universally. When you think of the platter-based storage, those disks are getting bigger in terms of capacity, but you're not getting any more IOPS out of them. So we have to do something in code to achieve greater efficiencies of storage use. One of the other challenges is around your databases. For years in Exchange, we've always had maximum recommended database sizes, and that holds true for Exchange 2013 as well. In fact, our maximum recommended sizes for databases in 2013 is the same as it was in 2010. 200 gigabytes if you're not replicating, 2 terabytes if you are replicating. But of course, the larger the data set means that in a JBOD environment, when you lose one of those disks, it's taking out a database with it, and you have to do a database reseed. And that is the other challenge with database copies, is those reseed operations, they have to be fast, they have to be reliable, and they have to be able to restore redundancy in a very quick and inexpensive and efficient manner as well. And then when you think about the types of database copies that we have, there's also the lag copy as well. And the lag copy has 2 particular challenges associated with it. One is that, well, they require manual care. So if you're in a page patching condition or some other scenario where something needs to be done to activate that lag copy, that's a manual process that you had to do in Exchange 2010, and it's something that we looked at to make better in Exchange 2013. The other challenge is with lag copies in particular, they have what we call asymmetric storage requirements. You need more disk for the lag copies because they hold up log files for longer than a regular passive or regular active copy would. And so because of those storage requirements, they bring some additional challenges as well. I think my clicker may have died. Oh, no, there it goes. Just too slow. Okay, so let's talk about the storage innovations. And again, all of these innovations are targeted towards JBOD, but every single one of them is supported in all of our supported storage paradigms. So the features we're going to talk about in the storage area, one is called multiple databases for volume. Another's called auto reseed. Then we've got some self-recovery behaviors that we have put in there, continuing some of the work that we did in Exchange 2010. And then we've also done some work around lagged copies to make them easier to care for and to give them the ability to do certain things that they didn't have before as well. Maybe I'm just getting too far away from it. All right, so let's talk about multiple databases per volume. Now, this actually is one of our features that has a name that is very self-explanatory. It's what it sounds like. It's hosting multiple databases on the same disk volume. So what might something like that look like? Well, here you've got an example of a nice symmetrical DAG. It's got 4 DAG members. It's got 4 databases. It's got 4 copies of each database. And on each volume, which is that gray cylinder below each server, that is a single volume. It's one JBOD disk in this example. And that one disk is formatted as a single partition. And under that single partition are subdirectories that contain multiple databases in this case. In this case, there are 4 databases. Each server has on this volume a active copy, 2 passive copies, and a lagged database copy. Now, this is just an example for illustration purposes. In other words, we don't require that you use a lagged copy for multiple databases per volume. That's something that's completely optional. If you want to use a lagged copy, if you've got the business case to do it, we totally support that, and you can use lagged copies. So this is just an example. Don't take this as to mean the only way that you can deploy this solution. Here I'm showing 4 databases per volume. You could do 3 or 2 or 5 or whatever works best for your environment, again, based on your business requirements. And you can see this is a pretty symmetrical design. We've got the same neighbors, the same databases on every volume on each server. So this is a nice even distribution as well. Now, why did we go down this route? Why have we literally taken our best practice recommendations that we've evolved in previous versions of Exchange and moved away from the pure isolation of just a single database and its log stream over to let's put all the databases and their logs and their content index on the one same disk? Why did we do that? Well, we did that for a couple reasons. First, we have done a lot of work over many versions of Exchange to reduce our disk I/O footprint, particularly around the passive database copy in Exchange 2013. And as a result of reducing those IOPS, now you can actually simultaneously have multiple database copies on the same disk volume without them choking out each other, without them fighting for the IOPS that might be available for that disk. And of course, the other reason has to do with some of those challenges that I talked about before, about your database sizes needing to be reasonable and reseeds needing to be fast and reliable. So let me illustrate what I mean by that. So just consider the simple scenario that you might have in Exchange 2010 today, or perhaps what some of you have deployed on 2013, with just using a single database per volume. So that's what this would look like as you can see on the screen. So what happens in a JBOD environment? Again, if I lose a disk, it's taking out that database with it. So DB1 was active on the first server, the disk died, and you can see it turns green on the second server as it gets activated on that server. So here's the DAG doing something wonderful for us, as it should, but now the administrator has a challenge. Now they've got to go possibly replace a failed disk, and of course, more importantly, they need to do a reseed operation so that they can restore redundancy and get all their database copies back. But herein lies the challenge. Today, you're buying very large disks. You may be buying 4 terabyte disks, for example. And if our maximum database size recommendation is 2 terabytes, and by the way, when we talk about 2 terabytes, we're not just looking at the database file itself. We're also looking at its log stream and its content index in that amount of space. So when you think about the fact that, well, I'm only going to occupy 2 terabytes out of a 4 terabyte drive, that's a lot of wasted capacity right there. And for those of you who've been doing Exchange for a long time, you know that Exchange in particular is very aggressive about using all available hardware. I don't mean the product, I mean the product group. I mean, the people who deploy or design, develop Exchange, we are very aggressive about making sure that customers can fully benefit from the hardware that they purchased. So that means using that capacity. We don't want you to have to make that decision as to whether or not I should fill up that disk or not. And here's why. Let's just say this isn't a 4 terabyte drive. Let's just say we're a year from now in the future, and maybe it's a 6 or an 8 terabyte drive. And 8 terabyte drives, by the way, are specifically what we've optimized for in Exchange 2013. So what happens when we have to reseed this disk operation? Well, if we're in a paradigm where we've got a single database per disk, obviously the amount of time it takes us to do that reseed operation will be based on how much data we have to seed. So if you stick to our best practice recommendation and you keep your databases to 2 terabytes or less, that's going to be about a 23-hour seeding operation, give or take. You know, it may be a little slower, a little faster, depending on your unique organization. But looking at the tests that we've done internally, we see about 20 megabyte per second throughput coming from a single source and seeding a single target. Okay, so that's about the throughput, and when you do the math at a 2 terabyte disk, it works out to be about 23 hours to do the reseed operation. But again, let's just say this was an 8 terabyte disk, and the administrator does not like losing perhaps 6 terabytes of capacity that they bought. That's most of the disk they're not even using. So they may decide, well, you know what? I'm going to ignore the best practice size recommendations, and instead I'm just going to grow the database and fill up that disk with, in this case, 8 terabytes. Well, that's going to be a much longer seeding operation. That's going to take about 93 hours to seed 8 terabytes worth of data onto that disk. So there are a couple problems for that. The first problem is it's going to take 93 hours. And that's a huge problem because that is operationally untenable. That is too long to wait for most organizations to be able to reestablish redundancy. But the other downside is that's also 8 terabytes of data coming in one seeding operation. And those of you who've done reseeds of databases, you know, for instance, in Exchange 2010, the seeding operation needs to be babysat. So, which means when the seeding operation kicks off, it has to be able to successfully seed all 8 terabytes of that data. And if it gets to 7.5 terabytes and there's some network hiccup that interrupts that, it has to start all the way back from the beginning again. So the two major problems, not just the amount of time it takes, but the reality of being able to reliably seed all of that data across the network in one stream at the same time. So, introducing multiple databases per volume. And this turns out to be a much better story because not only does it allow you to stay within our best practice size limitations, but it also allows you to get back into a place where you can actually seed a failed disk, even one that contains 8 terabytes of data, in an operationally reasonable amount of time. So again, by illustration purposes, we lose that disk, and in this case, we had 4 databases on there. So now instead of reseeding just a single database, now we've got to reseed 4 databases. So the admin replaces the disk, and they go ahead and initiate the seed operation. And there's 2 primary differences going on here. The most important primary difference, though, is the fact that we are seeding from multiple sources. So we're no longer source-bound. And in fact, it is the source in the seeding operation that will always be the bottleneck. It's not going to be the target. It's not going to be the network. It will always be whatever source we're trying to get the data off. That will always be the slowest point in seeding. So the fact that we're now seeding from multiple sources means that a lot of that bottleneck is gone. Now, certainly, 2 of the databases are being seeded from one of the servers, and so they'll go at about half rate, maybe anywhere from 12 to maybe 15 megabytes per second. The other 2, DB3 and DB4, that's the only seed operation happening from those servers, so they will go at full rate at about 20 megabytes per second. So now, if we were to seed 2 terabytes of data, which would be, split evenly across the 4 databases, so about 500 gigabyte databases each, that would be about 9.7 hours, or about 10 hours for the seeding operation. But if these were maximum size databases, if each of these 4 databases were 2 terabytes, reseeding an 8 terabyte disk through 4 separate seeds is now only going to take about 39 hours. So it's much more operationally tenable. It's a much better experience. So the benefits now you can see, you get the reduced seeding times, particularly when you've got multiple copies. But more importantly, as I said before, you get to leverage the capacity of the drive that you purchased. You get full value out of that disk because you filled it up with data. You didn't waste that extra space, and you stayed within our best practice guidelines for size recommendations as well. Now, multiple databases may not be for everyone. There are some small customers out there who, for whatever reason, don't want to or can't go to the cloud and may have a very small on-premises org that doesn't lend itself very well to multiple databases per volume. But many of you are in a situation where, especially if you're buying new hardware right now for Exchange 2013, you're in a great place right now to be able to adopt this and use this in your own production environments and save the cost savings and the time savings and stay within our best practices, but again, at the same time, maximize that database, or that disk that you bought. So the requirements are pretty basic. You just need a single volume per disk, so it's one partition, not a big deal. We do have some recommendations. We do recommend that the number of databases per volume be equal to the number of database copies that you have. As you saw in my example, that's symmetry there. It's not a requirement, but it is something that brings symmetry and gives you sort of this building block or brick architecture for deployment. And then we also recommend that you have the same neighbors on all servers as well, because that distribution of the database copies in that manner provides you with the most efficient and even distribution across not just your DAG members, but all of your database disks as well. All right. So that's multiple databases per volume. Another feature that we have that can be used with multiple databases per volume, or it can be used with a single database per volume, is called auto-reseed. So we saw in the last example that when we have a JBOD drive die, it takes out the databases, and the admin needs to replace the disk and do the reseed operation. Well, as you might imagine, running a service like Office 365 with more than 150 million mailboxes running in that service, we're going to see disks die all the time. And of course, anytime a disk dies in a JBOD environment, it's going to take out a database with it. And historically, what we've had to do is we have to dispatch an operator. It's what we call an administrator in the service. The operator would go out, they would replace the failed disk, and then they would initiate the reseed operation and then babysit it until it was finished. Now, for those of you keeping count, anytime we have to send an operator out to do something in the service, that's costing us money. And that interferes with our ability to give you a low-cost and cost-effective service for us to run as well. So we have mechanisms where if we see opportunities like this where we can automate it, we will do that. And in fact, that is what auto-reseed is. It's looking at the seeding challenges, again, on a JBOD environment where when that disk dies, it takes out the database copy with it. And anytime you lose a database copy, it's going to require a reseed operation to restore that redundancy. And it has to be fast, too, because you don't know what other failures might be lurking or about to happen. So you really want to make sure that redundancy is there at all times. And so the innovation is really this auto-reseed. And it's automatically reseeding a disk that was pre-provisioned as a spare by an administrator, automatically grabbing that disk and reseeding it. And then really the admin just has to replace the failed disk. They don't have to do all the other work. So the way it works here is I've got my server up in the middle there, and it's got a couple pools of storage. One is the in-use storage. Those are where actually my databases and log files are being stored. And then I've got some spare disks that I've provisioned as well. Here in my example, I've got 3, but you don't need 3. You could do it with 1 or 2 or however many are comfortable for you in your organization. So what happens is I lose one of my disks, and of course that takes the database out with it. And when auto-reseed detects this condition, and I'll walk you through the workflow in a minute, but when auto-reseed detects this condition, it will automatically grab one of those spare drives, map it into the appropriate structure, again, which I'll show you in a moment, and then it will invoke a reseed operation from whatever server just inherited the active copy of that database. So when that database was active on the server and it failed over to another server. That other server now has the active copy. It will be the source for a seeding operation for auto-reseed. And it's pretty cool because that means the admin just really needs to replace the failed disk, which in this case is from the spare pool. So it's a matter of pulling it out, putting the new one in, initializing, formatting, mapping it in the mount drive, and you're good to go. That's something that can be scripted and done in just a couple minutes. So the workflow for auto-reseed is it periodically scans the database copy status, and it's looking for databases that are in a failed and suspended state. And if it finds one of those, it'll go through our prereq checks, and I'll talk about what those are in a minute. And assuming the prereq checks pass, it will go ahead and map one of those spare drives that have been pre-provisioned. It will then start the seeding operation. When the seeding operation is complete, it will verify that the new copy is healthy, and then at that point, it's up to the administrator to go ahead and replace the failed disk. All right, let's dig a little deeper into how that works. So we look for database copies that are in a failed and suspended state, and they have to be in that state for more than 15 minutes. And if we find something in that state, we found in the service there's actually corner cases. I haven't heard of a single on-premise customer running into this, but in the service, we've seen instances where occasionally we will resume a database copy and it will not come out of suspend. So we have to run resume again, and then magically it will come out of suspend. And so what we do is when we find a copy that's in failed and suspended, we do actually try to resume it a few times first, just to see if it's in that case. And of course, if the resume doesn't work, then we'll go ahead and start the process of assigning the spare volume. If one is available. If one's not available, we go into a retry mode. And then once we've got the spare volume, if it is available, then it gets mapped in, and Exchange begins the seeding operation again from wherever that active copy moved to. And then Exchange monitors that. If the seeding operation fails or gets interrupted, it will restart it. As soon as it completes successfully, it will go on to the completion stage. But if it doesn't complete successfully, once all of the retry operations have tried, and you can see there's many, then the workflow stops periodically, and it sits and it waits for 3 days. And we do the 3-day wait because we recognize that it might not just be a disk error. It might actually be maybe a controller error, and you're waiting for spare parts. And so we wait for a while. Auto reseed has this timer that kicks in, and once we're in a place where we're waiting, after 3 days, if we find the copy still in that failed and suspended state, we simply begin the workflow from step 1 and go through it again until we're able to do it. And again, you can watch Auto reseed do its thing if you pay attention to the event log entries in the Crimson channel as well. So the prerequisites, well, there's several. For instance, the copy can't be reseed blocked or resume blocked. The logs and databases have to be on the same volume. The database and log structure have to use our hard-coded naming convention. I'll show you what that is in a minute. If you're using multiple databases per volume, none of the databases can be active on the volume that's about to be reseeded. And most importantly, all of the database copies on that volume must be in a failed and suspended state. So if you've got 4 databases per volume and one is failed and suspended and the other 3 are fine, auto reseed won't do anything. Or if 3 are failed and suspended and one is fine, auto reseed won't do anything. It's only there when the disk is actually dead. Actually dead typically means the operating system can't see it or Exchange cannot read from or write to it. That's a dead disk from our pod. And that's why when we talk about the end of auto reseed, when the workflow is the admin has to replace the disk, they will have to replace the disk because it will be a dead disk at that point. So there's no point in trying to recover the disk. And then there's other restrictions as well, such as, we limit the number of simultaneous reseeds that we'll do. And then we've got, again, that 2-day waiting period that we add in if we see database files there. So we've got the 3-day waiting period if we can't do anything, again, maybe because it's a controller problem. And then if the administrators left database files behind, maybe from a previous seed that they attempted manually, we won't do anything until 2 days have elapsed as long as those files are present. And then if the files are present and the timer has elapsed, we will wipe them out and proceed with the reseed operation. All right. Now, how do you configure it? Well, it's actually, you can take an existing DAG and you can retrofit it for auto reseed, but it's really best if you configure the DAG from the beginning for use without a reseed. In fact, that's the approach that we take with the calculator, and that's generally the approach that we would recommend that all customers take as well. And so the way it would work is you configure the storage subsystem, including spare disks. The number of spare disks that you choose to use is completely up to you. And then you create the DAG, you add the servers that have the storage to the DAG members, then you begin the process of creating a directory and mount point structure, and I'll show you what that looks like in a minute. Once you've done that, you'll configure the DAG. There's 3 new properties that you have to configure for auto reseed to work, and then you'll create your mailbox databases and your database copies at that point. So the things that you need to configure, let me let this animation build here. It looks complex and confusing, but it's actually a lot easier to understand than you'd think. So up at the top there, you see that circle that has the slash in it. Maybe my mouse will work and I can point it to it. This circle right here that has the slash. Let's start here. So remember I said that in multiple databases per volume, you have to format the drive as a single partition. That is the same requirement for auto reseed as well. So when we look at that circle with the slash in it, that is the root of that volume. So under the root of that volume are 2 other directories, one that I've shortened to exch vols, although by default it's Exchange volumes, and the other that I've shortened to EXCHDBs, and by default that's Exchange databases. I've shortened them here just to fit them nicely on the slide. Generally, I wouldn't recommend people use custom directories because it's non-standard, and auto-reseed likes to use its defaults anyway. So if you just want to stick with the Exchange volumes and Exchange databases, I think you'll be better served with that. But again, you can use custom directory names if you want to. Now, basically what we're doing is we're taking the same folders that are on this one single volume, and we're mounting them in two different places. We mount them one under the volumes folder, and we mount the other one under the databases folder. And those map to two of the three properties that you have to configure for the DAG. One is called this AutoDAG volumes root folder path. That points to the volumes. That is where auto-reseed and the DAG know where your in-use storage is. And then the other is the AutoDAG databases root folder path, and that points to the actual databases as well. So again, this is nothing more than just multiple mount points pointing to the same location. So underneath the volumes, again, that's where all of your storage is going to be. That's going to be your in-use storage and your spares as well. So you can see under volumes, I've got volume 1, volume 2, and volume 3. Now, under volume 1, you can see that there's this MDB1, and then below that MDB1.db and MDB1.log. Volume 2 has the same thing. There just wasn't enough room to show all that. And volume 3 doesn't have anything. It is my empty spare. And what you're seeing with this green MDB1, that's the folder where the database lives, and the green folder MDB2 is where the other MDB2 database lives. But because they're mount points of the same folder under two different subfolders, they appear twice. So this MDB1 is the same as this, and this is the same as this. Similarly, the MDB1.db, which is the hard-coded path you have to use for the database file, database name.db, is the same as this over here. And similarly, database.log is the same as this one over here. So again, it looks confusing, but it's just multiple things loaded in twice, if you will. The last property is this AutoDAG database copies per volume. And that is where you tell auto-reseed how many database copies are on that volume. So in my example, when I was using 4 databases per volume, I would have to set that property to a value of 4. And that's important because, again, remember, for auto-reseed to do its thing, all of the database copies on that drive have to be in a failed and suspended state. So it has to accurately know how many databases are on that drive. Now, this does not mean that every single database has to have the same number of copies or the same number of copies on each volume. Okay, so you can mix and match. You can have some databases where you do have 4 copies per database and 4 copies per volume. And then maybe you've got other databases where you've only got 2 or 3 and so forth. So you can combine them. But just be aware that whatever your intention for using auto-reseed, this property has to match the number that you're actually intending to reseed in a disk failure scenario. Because if it doesn't match, auto-reseed won't do anything for you. It's very picky in this way. All right, so the requirements, again, single logical partition per disk volume, not a big deal. It's pretty easy just to do that. We do have that specific database and log folder structure that has to be used. It's basically the paths that we use for deployment in the service. Auto-reseed was born in the service, and we didn't originally anticipate shipping it to on-premises. And so we hard-coded the directory naming structure that we use for our databases into auto-reseed. And so that means if you're going to use auto-reseed, you get to use our naming structure too. You'll have a mini version of Office 365, perhaps. So the recommendations, we want the same neighbors on all servers, just like with multiple databases per volume. And we do, again, recommend that the number of database copies equal the number of databases per volume as well. Not a requirement, just a good recommendation. Configuring auto-reseed can be a little bit tricky, but we've got great instructions for you with this URL. They were updated recently. There was a bug in one of the steps. Not any of the commands that you would run, but in the header of the step that said you were creating a directory when you were actually doing something else. So that header's been changed, and it's been updated as of April. And for all of you interested in doing auto-reseed, I would love to have you try these instructions because I'm fairly confident they are bulletproof. But I invite you to prove me wrong, and if you find a mistake with them, contact me directly, and I'll get it fixed up that day for you. All right. There are numerous fixes in CU1. If you've been playing with auto reseed and RTM, in CU1 we fixed a bunch of stuff. We fixed a bunch of stuff like auto reseed not detecting spares, or auto reseed detecting the spares but not using the spares. There's also some performance issues that we fixed and so forth. So again, any of you who might still be running RTM code, you really need to be up on CU1 when you go to deploy these things. Some of the other seeding innovations as well, the commandlet that we use to seed, update mailbox database copy, we've added some new parameters that lend themselves to automation. So things like scripting. If you want to script a seeding operation, you now have that ability. So for instance, you could use the new begin seed parameter that we have. And what that will do is that will go ahead and initiate the seed and then exit the command. And it'll just go ahead and do the seed in the background. And this is great because without that parameter, you basically have the seeding operation open and going the whole time. And if anything interrupts that, you get to start back from the beginning. So this is fantastic even if you're not planning on scripting all of your seeding operations because of this automation. Maximum seeds in parallel, you have the ability now to specify in tandem with the server parameter the number of maximum seeds that you will allow a server to incur. So again, if you like to limit or cap the type of activity going on your servers, you can do that now with these as well. And then the last one is that safe delete existing files. And this is great because this parameter in particular requires a little bit lower level of privileges required to do this operation. And so that means a subordinate administrator, somebody with lower RBAC privileges, could go ahead and invoke a seeding operation. They don't need to be a DAG administrator, if you will, in order to have permissions to do this now like they did previously. Okay. Take the curtain back on self-recovery from storage failures. Now, this is not entirely new in Exchange 2013. We recognized long ago, in fact, that storage controllers are kind of like mini PCs, and they can crash and they can hang, or other loss of vital system components can happen, or operator error can happen, and so forth. And so what we wanted to do for these is we wanted to give Exchange the ability to recover from these automatically. And in fact, in Exchange 2010, we started that process. We did things like ESC database hung I/O. Okay, if we can write to or read from a database within 240 seconds, we will automatically recover that behavior. How? Well, we forcibly reboot the box to recover from that. How do we do that? Well, the replication service terminates the win-init.exe process. And when you do that, that causes a bug check or a blue screen. Okay, and it's a very unique blue screen as well. It will be the same blue screen code every time. And you can look up that code, and it will take you right into the Exchange documentation that tells you what happened and what we did. And in fact, if you're really curious to look at that code now, go ahead and log in as an administrator on your laptop. Fire up Task Manager, locate the win-init.exe process, right-click and choose End Task. And then don't get mad at me when your laptop blue screens. Okay. So some of the other things that we did, we carried all of the Exchange 2010 stuff into 2013, but we added more to it as well. So things like system bad state. This is when the system is in such a bad state that threads just aren't getting scheduled anymore, including managed code threads. And if we see the system in this state for about 302 seconds, we will correct that, again, by forcibly rebooting the box, bug checking the box. Similarly, long I/O times. Of course, long is relative, but 41 seconds for an I/O to go out and come back, that's a very long time, particularly from an Exchange perspective. That usually tends to indicate that maybe a disk is about to fail or that something otherwise catastrophic is about to happen with the hardware. If we see that, we'll try to fix that, again, by forcibly rebooting the box. Now, the replication service, the memory threshold, that's a little different. Yes, it's not a storage-type recovery, but it still is a self-recovery mechanism, so I wanted to include it in here as well. And basically, the way this works is if we see the working set of the replication service get to 4 gigs or higher, we will go ahead and first try to correct the problem by restarting it, and if the restart doesn't solve it, then we'll go ahead and bug check that box the second time. Now, that's what we've done in 2013 RTM. In CU1, we also added other behaviors. So one behavior is the bus reset event. Whenever we see a bus reset happen, that typically means that storage is going to go down and it's going to require an admin to come and push a button to get it back up. So when we see that, as evidenced by event ID 129, when we see that event happen, we will fire an event into the Crimson channel that tells, once again, Active Manager to recover from that by forcibly rebooting the box. Similarly, the replication service endpoint's not responding. If we can't make a connection to the replication service, again, we will forcibly reboot the box to fix that. The last one, we haven't really talked too much about yet, the cluster database hang updates that we did. This is really for Windows Server 2008 R2. So if you're running Exchange 2013 on 2008 R2, the cluster team did some great updating work for us with respect to Cluster's Global Update Manager. That's what GUM stands for. When the Global Update Manager is in a very busy cluster, it's possible where updates from one server may block updates from another one and actually cause a hang of the cluster database itself. And when the cluster database hangs, it can cause a node to do all sorts of funky things. And so now what we've done is the cluster team has instrumented clustering more for us, and they've distributed a hotfix for Windows 2008 R2. And when this hotfix is installed, we get much more richer information about GUM updates and what's happening at the cluster level from the system. And so as a result of getting that information, when we see the new codes from the cluster team that tell us it's blocked, now we have the ability to correct that by, again, forcibly rebooting that box. And as you might imagine, as we continue going down the life of Exchange, I think you'll see more and more of these types of self-recovery mechanisms coming into the product. All right, let's talk about the lag copy innovations. So in terms of the lag copy innovations, I already talked about some of the challenges. The fact that activation is difficult. It's all a manual process, the fact that they require manual care, and the fact that they cannot be page patched. So if we encounter some sort of database corruption or maybe a disk problem that causes database corruption, we can't do anything with the 2010 lag copy because the corrupt page might not even exist at that point. So what we've done with lag copies is we've introduced innovations that basically allow them to sort of care for themselves in certain scenarios. So what I mean by that is the lag copy can automatically start playing down its lag log files and bringing itself more up to date. So for instance, a low disk space condition. In 2010, you really have no agility from a low disk space condition. About the best you could do is maybe throw away the content index catalog and buy yourself maybe a couple gigabytes of breathing room that way. But in 2013, now you have the ability to have Exchange automatically detect that for your lag copies and bring itself up to date. Now, the low disk space threshold is about 10%. So once we get into that condition, we will start to automatically play down the lag. And as we play down those log files, we will remove the ones we don't need anymore from the system, thereby freeing up space. And we will continue playing down the log files until we are back below that threshold. So that could mean maybe bringing it all the way up to date, or it might be bringing it only so much up to date. Maybe just a few logs need to be played in order to get back under the threshold. Or similarly, page patching. When we encounter the scenario where we know a lag copy is going to need to be page patched, we play it forward to the point where it now has the page that needs patching in its database, and then we will go ahead and invoke the page patching operation. And then the third scenario is when redundancy is at risk, when you've got fewer than X numbers of database copies in a single AD site for Y time period. So the default is 3 copies within a 24-hour time period, but you have some control and you can configure some of those settings. Again, in that case, if the lag copy, for example, ends up being your only existing passive copy, the system can automatically bring that up to date and turn it into a viable candidate for failover at that point. The other big thing that we've done with lag copies is we've integrated it with the transport safety net feature. If you're not familiar with safety net, first I would recommend going to Ross's transport architecture session later on today. But if you can't make that, safety net is basically the replacement for transport dumpster. It's where we hold messages inside a hidden queue in transport in case they are needed by a database that's being recovered or a database that's just undergone a lossy failover. So it's just like transport dumpster, with one cool exception. It's no longer size-based. It's only time-based. So in transport dumpster, that was size and time. So you might say, oh, keep everything for 7 days, but only let it grow to 18 megabytes. So a very large message could come in and throw all the other messages out and compromise your ability to get data back. Now it's just time-based, so it's just going to grow and grow and grow for that time period. But what's beautiful about this, where the integration comes into play, is when your safety net retention period is greater than or equal to your lag copy period as well. Okay, so say, for instance, you have a 7-day lag on your lag copy, and you have a 7 or 8-day safety net retention period. That means if you want to activate your lag copy and just have it be brought up to date, you don't necessarily need to have to go through log replay. You can actually just mount that database with whatever required logs it needs to come up, and once you've done that, it will recognize itself as a recovered database that is missing messages, and it will automatically request resubmission of those messages from SafetyNet and basically bring itself up to date with those messages. Now, that may or may not be preferable to you. Okay, remember, the logs represent physical changes, and that could be somebody opening one of those messages and maybe doing something to it. Okay, so that means if you're not replaying those logs, if you're instead going back and getting the original message, those changes could be lost. So keep that in mind. That may be a trade-off that you don't want to do, that you decide instead to go ahead and just do the normal log replay and let it bring it up to date that way. The choice is up to yours. Either way, you've got a much easier way to activate that lag copy now. All right. So that was the storage area. Let's talk about high availability now. So the high availability challenges, how many of you were at Ross's managed availability session? All right. Great. So for those of you who weren't, one of the things that we talked about was the fact that when you look at the health model in Exchange 2010, particularly around high availability, we're really largely focused just on database health. The database, the content index, copy queue, replay queue, that's about it. But because of the architectural changes we made in 2013, that is no longer good enough for 2013. The way we do things now requires that we need so much more than just a good database and a good content index to fail over to. So that's one of the challenges. The other challenge is around DAG networking configuration. Believe it or not, it is our dream to not have you ever have to configure DAG networks. We want you to just configure your NICs, and when you install Exchange and put that server into a DAG, we will take it from there. Okay? So let's see what we've done there. In terms of the innovation, we've introduced managed availability, and I'm just going to explain it briefly because Ross did a fantastic job yesterday, and I would strongly recommend that everybody go see that recorded session. I'm going to talk about best copy and server selection, which is new in 2013, and we'll talk about DAG network autoconfig. So managed availability is basically a reflection of the recognition that all access to anybody's mailbox is now driven through the protocol stack on whatever mailbox server hosts the active copy of their database. Which means it doesn't necessarily matter how healthy the database is. If the protocol stack is down, no one's getting into their databases via that protocol. Okay, and so managed availability is there to look for problems in the protocol stack or problems in the dependency stack and to automatically recover from them as soon as they're detected, assuming they are recoverable. So it's high availability that now extends to all the rest of Exchange. We still have all the good stuff that we're doing with Active Manager and the DAG, but now we've got managed availability that is giving you HA throughout the rest of the system. And HA is actually an internal framework that we use. It's developed internally and designed internally and implemented internally. So it's nothing that you really need to do any of the heavy lifting. I know that some customers get really nervous when we talk about frameworks because it usually means that here's the bare bones and guess what, customer, you have to do the rest. That's not what we're saying here at all. The framework was actually developed by the monitoring team for Office 365 and then imposed on all of the other Exchange component teams. So the OA team, the ActiveSync team, the Web Services team, the People and Calendaring team, the Store team, the Active Directory team, all the different component teams have their own managed availability components that they work with. And managed availability not only gives us this user-oriented monitoring and recovery actions, but it also provides us with new enhancements and a change in the algorithm that we used for the best copy selection process as well. So managed availability, when it's correcting things, that means it can also do things like failover. It can fail over a database or it can fail over a server. So for instance, if you had a store problem on the database, a problem with a single database, you might just fail over that one database. Maybe this poison message got into it, and every time you try to mount on that server, it just crashes that one database. Or it might be a server-wide area. Maybe for whatever reason, IIS is not running, or the OA protocol is down, so it's a server-wide failure. That would trigger a managed availability server failover. And these are not the same exact types of failover that Active Manager might trigger, but you can think of them that way. Okay, so the things that Active Manager are doing, think of it that managed availability is also doing it, but for other reasons, non-DAG related reasons. The other thing that we did was we also integrated that single copy alert that we introduced in Exchange 2010. That now runs as part of the data protection health set and managed availability as well. So that was that redundancy check that we initially deployed as a script that you would run in Task Manager periodically, and it would look for scenarios in which you had a replicated copy, a replicated database down to one single copy. That was something that we actually thought was very important to get in your hands because particularly in a JBOD environment, if you're down to just a single copy of a database, then you're at perhaps extreme risk. If that disk dies, it's going to take all of your data with it. So what we've done is we've now integrated the single copy alert, which means you don't have to run the script, the check database redundancy script, and it means you don't have to set up that script in Task Manager anymore. And of course, you didn't have to set it up in Task Manager in 2010 SP2 because we started doing that automatically for you. But now you don't have to set it up at all, and more importantly, it also now means that the Task Manager service, unlike Exchange 2010, is now no longer required for your 2013 mailbox servers. Okay, in 2010, we required the Task Manager, the Task Scheduler service, for all of your 2010 mailbox servers. That was a hard-coded requirement. Without it, you couldn't deploy a mailbox server. 2013, that requirement is gone. We don't need the Task Scheduler service anymore. All right, let's talk about best copy and server selection. So again, the challenges around BCS goes back to what I was saying earlier about the health model that we use in Exchange 2010. Exchange 2010 is just looking at your database health, your content index health, the copy queue length, and the replay queue length, and it's going through all these series of criteria to figure out if I have a viable candidate for failover. Okay, and that worked great in 2010 because of the architecture we had in 2010. It doesn't work so well in Exchange 2013 because it's not telling us the whole story. If I just look at the database, that doesn't tell me if the protocols are working. If I'm just looking at content index or queue lengths, that's not going to tell me if when I move users over there, are they going to be able to get into the service and access everything, or are they going to encounter errors? And so we changed best copy selection. And in fact, it has a new name. We now call it best copy and server selection. And that new name is largely a reflection of the fact that we're not just looking at the copy status anymore. We are looking at the overall health of the server itself. And not just the server that might be a viable target for activation, we're also evaluating the server's health where the failure took place as well. Because we use that for comparative purposes in the new algorithm I'm going to show you that basically enforces a constraint that failover will never make anything worse. It might not make things better. Things might end up the same as where they are, but with the new algorithm that we have, it imposes these constraints that failover will never make anything worse than it already is. So when we have to do best copy and server selection, it's still Active Manager for the DAG. It's still happening at star overtime, which would be a failover or a targetless switchover. Targetless switchover is when the admin does a switchover, but they don't specify which server to move the databases to, and they let Active Manager choose it. So anytime Active Manager is choosing the target, that will invoke BCSS. When we're looking at replication health, we still use the same exact criteria. And those 10 phases that you may have seen in some of the 2010 presentations I've done or out on TechNet, we still use that for the replication health part of it. But now, we also include the criteria for the health of the entire protocol stack as well. We've got new constraints, doing new evaluations, giving us new data that we use to evaluate whether or not we can fail over to that target. And basically the way it works is managed availability is now imposing 4 new constraints on the best copy selection algorithm. And that changes it to best copy and server selection. So the first constraint is what we call all healthy. So here what we're doing is we're looking for a server in the DAG that has a viable passive copy for activation whose managed availability health sets are all in a healthy state. There's nothing being reported by managed availability as being in unhealthy. This would be our best possible candidate for activation. If we cannot find a server that meets that criteria, then we will look for one what we call up to normal healthy. Now again, hopefully you'll go see Ross's presentation, but managed availability, all of the health sets also have a priority associated with them as well. As you might imagine, some health sets have higher priority than others. For instance, the Active Directory health set is going to be a higher priority health set than, say, for example, the IMAP health set. Okay, it's more important than AD be running than IMAP, because if AD is down, no one's getting into Exchange. And we recognize the uses of the different protocols and aspects of Exchange in our priorities. So we look at all the health sets that have up to a normal priority, or what we call medium or above, and if we find them that are all in a healthy state, then this would be our candidate for activation. And if we can't find a server that meets that criteria, we will look for one that says all better than source. So again, we are looking at where the failure originally occurred, and we are evaluating that against the servers that may be candidates for activation. So if the original failure was, well, IIS crashed, and that took out a bunch of protocols, and now IIS isn't running, and we need to fail over, what that means is, well, we need to find a server that has IIS in a healthy state, in a better state than what the source was in. And of course, if we can't find a server that meets that criteria, then we look for something that is what we call same as source. Okay, sure, it might not get us any better. We might end up in a situation that is exactly where we are right now, but who knows? Maybe it'll make things better, maybe it won't. But because of the constraints that we have here, we know it won't make things worse, because we're always looking for a server that's at least as good as where the failure happened. We try to find one that's better first, but we'll fall back to it's just as good. Maybe it'll perform better somehow, or something magical or better will happen. But we won't say, well, just go over there because it has a healthy database and the protocols are down, but the database is great. We won't do that. We will never make things worse than they already are because of these constraints that we've imposed. Okay. Now, there are some changes in CU1 that we introduced as well. How many of you are familiar with the maximum active databases parameters that you can set with Set Mailbox Server? Okay, a few of you. So we give you the ability to actually cap the maximum number of active databases. So even, say for instance, with the Enterprise Edition, you can have a maximum of 50 databases per server. Maybe the resources that you bought say, well, at any given time, I really only want to run 35 databases per server. So you can set that cap. Now, one of the challenges that we had previously before CU1 is that Active Manager, as part of this BCS process, was not tracking or looking at that cap until we actually issued the mount operation. So we would evaluate the server, we'd say, oh, life is good, go ahead and try and activate that, and we'd begin the activation process, and then we'd try to mount the database, and we would get an error message back saying, nope, too many mounted databases, max actives is reached, try another one. And so now Active Manager has to go back to another candidate and redo the whole process from the start. That was extremely inefficient and not the best way to do it. So now what we do is the primary Active Manager actually tracks the number of active databases on each server now. And so we have that information, and if the PAM moves around, that information travels with it, or if the PAM crashes and it's lost, it's rebuilt automatically from the cluster database when the PAM comes back up. So PAM knows, and remember it's PAM that does the activation itself, so PAM now knows which servers are at their limit or not. So if it detects that, oh, server B already has 35 databases running, and that's its limit, it won't even consider it now as a candidate for activation as a result of that. So no more activation thrashing. And you might even see, failovers happening even faster than they're already faster in 2013. And by that I mean in 2010, we were seeing failovers in about maybe 20 seconds in our dog food environment. With 2013, we see failovers happen in about 10 seconds in our dog food environment. So failover is about twice as fast now as it was in 2010. All right. Let's talk about the DAG network innovations. And again, this represents a bunch of work that we've done over multiple releases, believe it or not, work that we started with 2007 and CCR, moving away from having administrators have to manually set up cluster networks or DAG networks and things like that. And we wanted to basically cover all scenarios. And we got pretty far in 2010, we just didn't cover them all, particularly one of the more common ones, unfortunately, which would be the multi-subnet deployment. So in a multi-subnet deployment in 2010, you had to do this extra special step of collapsing your DAG networks. And if you didn't do that, even if you had a MAPI and a replication network, we would never use a replication network. We would always and only use the MAPI network. Then when you collapsed your networks properly, which was a really quick and easy thing to do, but still some customers didn't do it. But once you collapsed them, then everything would work great, and we would use that replication network. Well, now we are eliminating those challenges for you. So what that means is if you deploy a DAG in a multi-subnet environment, we will automatically collapse your DAG networks for you. You don't have to do that anymore. There's still a couple things that you have to do. For instance, you got to configure the NICs correctly. And if you are in a multi-NIC configuration where you have a MAPI and a replication network, you still do have to configure that static routing for the replication network. But those are very minor and inconsequential one-time operations. Okay, it's not like you have to go and collapse your DAG networks anymore. And in fact, by default, out of the box with 2013, all DAG networks are set to automatic configuration. Basically, sort of a read-only configuration that is managed by the DAG. Now, the administrator can go in and change that to manual, and I'll show you how to do that in a minute. And then they can configure things, but out of the box, the behavior's changed. You don't get the same experience with DAG networks as you got with Exchange 2010. So, let me show you what I mean by that. So here's a DAG. Here we are in the Exchange Admin Center. If you haven't seen this before, this is the primary web-based interface for Exchange 2013. And as you can see here, I've got my DAG, DAG1. It's got a couple servers in it, and it's got a witness server configured. And I've got two DAG networks, one called MAPI DAG Network, the other one called Replication DAG Network 01. So I've left them with the default names here. But as you can see, I don't really have anything I can click on here. This is just read-only information. If I wanted to actually view the configuration, I need to do one of two things. I can either go to a PowerShell and enumerate it using Get Database Availability Group Network and see it that way, or I can select the DAG and then click Edit, and then look for this box that says Configure Database Availability Group Networks manually. And then I check this box, I click Save, and now you can see things magically appear. I can do things like disable replication, I can remove a network, I can view details. And so, for instance, if I click View Details, now I can see all the details of my DAG network right here. Okay, I can see the name of it, I can see an optional description, the subnets, whether or not they're up, and I can see whether or not replication is enabled as well. So that's the MAPI DAG network, and there's the replication DAG network. But until you change from from automatic to manual configuration, you won't be able to see any of this in the Exchange Admin Center. You'll have to see it all from the shell. And of course, until you change it to manual configuration, you won't be able to change anything from the shell as well. Okay? Now, generally, you shouldn't have to change too much with your DAG networks. There may be cases where you're maybe resubnetting the DAG, and that's a very quick, change the IP, bounce the server, and you're good to go kind of operation. So really, you shouldn't have to mess too much with DAG networks beyond the two configuration things I mentioned earlier. All right. All right, let's talk about site resilience now. How many of you are deploying Exchange in a site resilient configuration? All right. How many of you are doing that with 2010? All right. How many of you are going to do that with 2013? Great. How many of you have 2 data centers? How many of you have more than 2 data centers? Ooh. How many of you have 3? How many have 4? 5? 6? Anybody have 10 data centers? 10. Do I hear 10? 10 going once. Going 10? All right. And your stock symbol was? Yeah, okay. Oh, education. Oh, never mind. Sure. Yeah, absolutely. So those of you doing Exchange 2010 site resilience, I don't need to talk to these to you. You already know it can be difficult and challenging. You know, for instance, it's operationally complex. And there's no automatic nature in Exchange 2010, which means admins have to get involved, things need to change, stuff needs to get moved, and it can be a very long and laborious process that, until you've gone through it a few times, is going to be pretty error-prone. The other challenge in Exchange 2010 in particular is that the mailbox and client access, the recovery of them, they were coupled together. And in fact, it wasn't just a recovery, it was almost every aspect of those 2 server roles were very tightly coupled together. And then, of course, the biggest challenge that you have with Exchange 2010 Site Resilience is the namespace, the URL that you give to your users. I would argue that is, in fact, the biggest single point of failure that you'll have in your whole system. Why? Because it's the namespace that tells the users where to go. And if the namespace is down, users aren't going anywhere. So those are the site resilience challenges. What is really great, I think, about what we've done in Exchange 2013 is that all of the innovations we've introduced have actually made everything the exact opposite of what you see here. So what we mean by that or things are operationally simplified, mailbox has been decoupled, and recovery is a lot simpler. But before we talk about that, you have to understand some of the new key characteristics in this. Because I want you to realize why you can do new and interesting things in 2013 that you couldn't do and can't do still in Exchange 2010. So for one thing, when you think about the key characteristics, sure, we're using DNS resolving to multiple IP addresses. That's not new. People have been doing that on the internet for years and years and years. You've experienced that behavior every day that you've ever gone on the internet. Maybe you were aware of that, maybe not, but that's what's going on. I'll tell you how to verify that in a minute. The other thing that we did is with the architectural changes we made, almost all protocol access now, including the Outlook client, is HTTP based. Yes, there's non-HTTP access in there, but the majority of clients that are now connecting are all HTTP based. That's an important key difference between 2013 and 2010. However, that does not mean if you suddenly deploy Outlook anywhere on 2010, you can do all this stuff. You can't. HTTP clients, most modern ones, and by modern I mean clients that are newer than 10 years old, or older, maybe 12 years old, they all have built-in IP failover capabilities. So that could be, a very old operating system. It could be something like Windows XP, or it could be any newer version of Windows before that. It could also be any mobile device that all of you are carrying, or any other OS or browser that's been around for more than the last decade. They all have their own built-in HTTP caches and their own HTTP failover capabilities for multiple IP addresses. And the way it works is when the client side has multiple IP addresses, if it gets a hard error, it can't make a TCP connection to one of those addresses, it will automatically try the next address in its list. So it's very easy to see this for yourself. Go and fire up NSLookup and just simply type in www.bing.com. And what you'll see is a bunch of addresses come back. If you've got IPv6 enabled, first you'll get a couple IPv6 addresses, and then you'll get IPv4 addresses, which are given to you in a randomized order by the DNS server. And in fact, you can verify that by just hitting the arrow up key and doing the same query again for www.bing.com, and you'll notice that the IP4 address list you got before is now different. It just rotated the order and it changed it. So it's a combination of things. It's round-robin DNS on the server side, and the client's ability to get multiple addresses and fail over to an address when one of them does not give it a TCP connection. And of course, the admin has control of this stuff. The admin can go ahead and take a failed IP address out of DNS and stop connections from going there in the first place. But what it means is two important things from a site resilience standpoint. The most important things, now the namespace is no longer a single point of failure. But more importantly, it also means that in some failure scenarios, depending on your business requirements and your configuration, you don't necessarily need to manually do a switchover anymore. You may be able to get a data center failover out of the system, and that means no dealing with DNS latency. Now, here we are in North America. It sounds silly to talk about dealing with DNS latency because we really don't have a lot of that here. But in some parts of the world, DNS latency is very, very bad. There are some places where it could take more than a day for DNS records to get updated throughout the system. And so that means downtime until those clients pick up that new address in the old paradigm. In the new paradigm, there is no dealing with DNS latency because as soon as the client does resolution, it gets the multiple IP addresses already. So it already knows multiple points to try if one of them is not available. All right, so let's talk about the innovations. It's operationally simplified. Mailbox and CAS have been decoupled. And the namespace provides redundancy. So what do we mean by these things? Operationally simplified. Well, it means in 2010, when you lost your CAS array or the load balancer that was in front of it, or your load balancer itself, or the VIP, or part of your DAG, or all the DAG, or so forth, you had to do a data center switchover. Okay, even if it was just a CAS array that you lost and your DAG was 100% healthy, you had to move everything over to a secondary data center and do a manual data center switchover. In Exchange 2013, that is no longer always the case. In 2013, you may have the ability to have the system just automatically fail over to another data center in response to one of these actions happening. What do we mean by mailbox and CAS recovery independent? And again, same thing. If you lost, say, for instance, the majority of your DAG and you had to activate the DAG members in a secondary data center, guess what? You had to move your namespace over there as well. Okay, so that means even though CAS may be healthy, the load balancer may be healthy, the CAS array is fine, DNS is good to go, but guess what? Because you had a problem with the DAG in 2010, you had to move everything over. Okay, again, it's not the case in 2013. In 2013, failover of CAS or failover in the DAG, they are completely independent of one another. And same with the recovery aspects as well. They are completely decoupled. I no longer need to recover the namespace just because I'm recovering my DAG. I no longer need to recover the DAG just because there's something wrong with the namespace or the front end of things as well. And what do we mean by the namespace provides redundancy? Well, again, previously it was a single point of failure, but now in Exchange 2013, we are now exploiting these HTTP clients' ability to get multiple IP address, and we're incorporated that into a workflow that gives you this automatic failover, even for data center level events. All right, so what does that mean? Well, that means we now have support for new deployment scenarios. Now, again, I want to caution that don't try to do this in Exchange 2010. You cannot. If you look at all the things on this slide, pay particular attention to everything that's underlined, because we had to do all of those underlined things in Exchange 2013 in order to make this happen. And because none of those underlying things happened in 2010, you cannot make this happen in Exchange 2010. This is 2013 only. But basically, the new deployment scenario is now if you have more than 2 data centers, sometimes we call it 3 data centers, sometimes we say 2.5 data center. Actually, 2.5 comes from one of the HAPMs I work with. I don't like the 2.5 because what's half a data center? I don't know what that is. So I always like to say 3 to let people know, yeah, it's really got to be a third location. But what it means is if you have a third location, a location where you could deploy a witness server for your DAG, that means if you lose either site, because of all the changes that we made in 2013, you can get automatic site failover for the DAG in this configuration. Now, of course, you have to have at least 3 locations. But I want to be clear about one thing in particular. No one is saying go out and get a third location so you can do this. Okay? The cost of goods are not worth it. Okay, if you have more than 2 locations, you now have a new option available to you. If you don't have more than 2 locations, then it's not going to be cost effective for you to go and acquire a third location just to get these behaviors. So don't go out there and say, oh great, bought 2013, went to TechEd, now I was told I need 3 locations. You don't, okay? You can still have a great experience with 2 locations. We are just giving you an extra deployment option if you happen to have more than 2. And the 2 locations will be your Exchange data centers. They have to be well connected for replication and AD and all that other stuff. But the third site, that can be maybe a branch office. It could be somewhere, geographically distant from you. It doesn't have to be as well connected. Its most important criteria is that it will be isolated from network failures that affect the other 2 sites. And as long as you've got that, then again, you've got the ability to put that witness server in that third location, provided it's managed well, and then have the ability for the DAG to give you the failover capabilities across sites. I will take your questions in a minute, but I want to show you some examples first. So in terms of the site failover resilience, or site resilience failover example, let's start with the front end, that client behavior that we talked about. So the way it works is I've got Contoso.com here, our favorite entity. They've got 2 data centers, one in Redmond, one in Portland. Both are internet facing, so both of them have a virtual IP address available that clients connect to. The administrator's gone into DNS and they've set up mail.contoso.com twice. 2 A records, one that points to the 192.168 address, one that points to the 10.0 address. When I'm a user and I open up my laptop and I fire up one of my clients and I resolve mail.contoso.com, I'm going to get both addresses back. And again, they're going to be randomized by the server. Maybe the 192 will come first, maybe the 10.0 will come first. It doesn't really matter as long as I have a connection endpoint that can get me to my mailbox. And what happens is if you lose one of those endpoints, say for instance, we don't even lose all of Redmond, we just lost the load balancer that was supporting that VIP. So everything else behind that VIP is still fine, but the VIP is down, so clients can't make a TCP connection to it anymore. Well, clients already have the other address, and if they can't make a TCP connection to the first address, they will wait 20 seconds, and then on the 21st second, they will try the next address in their list. So once the client couldn't make the connection to 192.168, after a 20-second waiting period, it will automatically, by itself, without the user doing anything, try the 10.0.1 address and hopefully get connected at that point. And of course, if the administrator wants to, if they don't like that extra 20-second wait, they can go to DNS and they can take the failed VIP out of DNS. Whether or not you do this is really going to be scenario dependent. If the failure is such that the load balancer was just misconfigured, it's not really dead, or it's not a hardware failure, someone's going to be reconfiguring it in the next 10 minutes and it'll be back up, you probably don't want to make that DNS change. But if it's the load balancer just caught fire and we're not going to be able to get a replacement one for 2 days, then you might want to go in and change DNS, and that way direct all the traffic and not give that 20-second delay for some of your users. But again, the choice will be yours as to whether or not you actually do that. Now, let's talk about the DAG side. Now, let's look at the 3-location scenario first. So again, Redmond and Portland are my 2 primary sites, and I've got my witness server in Paris. And actually having the witness server in Paris means it's on a different continent from my 2 Exchange servers. And that's actually a practice taken from the service as well. That's what we do in Office 365. We always take our witness server and we put it on a different continent from the DAG members that it hosts. And we do that because if you've ever seen the pictures of the actual fiber networking cables that go under the ocean, there's some geographic areas, particularly around Asia, where there's just one cable, and that cable gets severed. It takes out that whole entire region. And so what we do to account for things like that, to isolate the witness server site from network failures that affect the other Exchange sites, again, we put the witness server on a different continent. And I chose Paris because I like to visit my witness server every summer for 2 weeks. So, Paris. Okay, so how does it work? And I'm sure many of you understand already how this works. You lose your DAG members, and basically what's going to happen is, as long as 3 and 4 are operating and they're isolated from whatever failure happened in Redmond, 3 and 4, one of them will lock that witness server, and boom, automatic failover of your databases will occur, and your DAG will maintain quorum and will stay up and continue running, and life will be good. Then it's just up to the administrator to go in and fix whatever issue happened that caused the failure in the first place. Okay, so you get a much better experience when you have that 3 data center topology. But guess what? You also get a much better experience when you've got 2 data centers as well. Because again, of all of those underlying things that we talked about on the other slide. So this experience, now we just have Redmond and Portland, no more 3rd site for the witness. Redmond would be considered my primary data center, so I've got my witness in there. Same scenario, I lose my primary site, and of course in this case, the loss of the primary site means the loss of the majority of the quorum voters, which goes and takes down the remaining minority of voters as well. But guess what? That just means you do a data center switchover, but because we've decoupled CAS and mailbox and consolidated the server roles, really all that means is you just have to run 3 commands to get your DAG back up and running. So that would be these 3 commands, literally. That's all you need to run, and boom, your DAG is back up and running. Your databases are mounted, assuming they're not activation blocked, and users are back in and doing everything. So if you haven't seen these steps before, they're the first 3 steps that you would do in a 2010 data center switchover to activate the DAG portion in a site resilience configuration. This is all you need to do in 2013 because of all the work that we've done to decouple things. So even if you only have 2 locations, your recovery times just got significantly reduced over Exchange 2010. So you still have a much better experience, even without 3 locations, than you ever did in Exchange 2010. All right. Now, I guess I have some announcements to make in the last 3 minutes. So let's see what we have here. All right. So, coming in CU2. Now, this is what I've been building buzz about all week. These are major life-changing announcements that are about to happen. Okay, so I want to pause for a minute and give you a moment to reflect on this, because this is going to be a real before and after kind of moment for you. So think about your life now and what it's like. And now let's see what it's going to be like. So here it is, the big announcement coming in CU2. Sorry, the curtains are slow. Is a new DAG management service. Yeah. So MS Exchange DAG management. Okay, what we found is that the replication service was growing too large, was doing too much work. So in CU2, we're taking the monitoring component out of the replication service, and we're putting it into a brand new service called the Microsoft Exchange DAG Management Service, or MS Exchange DAG MGMT service as well. And you'll see eventually further functionality will move into that service as well. So when you deploy CU2, you will now have a brand new service on your DAGs that will be doing additional work that we were doing before, but now in a different process for better scalability and better performance. Is that awesome or what? Yeah. All right. Okay. Really, here's the announcement. Coming in CU2. But I have to caveat this. I have to say possibly. Possibly. The DAG management service, I mean, marketing wants me to say possibly, but the fact is it's checked in and it's in the build. It's there. You're going to see it. The Azure stuff we're still working on. I'm working with CSS and Windows and Exchange, and we're actually trying to validate use of Azure for your witness server. Now, a couple things I need to point about this. One is that even if we get this to work, you might not want to do it because it's going to require you to take your corporate Active Directory and extend your permissions to the cloud. Basically, roll out a DC in the cloud and an Azure IaaS. Okay, so keep that in mind. It's going to require that, and it's going to require Azure as well. But this really is not for everybody, okay? This is really only for existing Azure subscribers. The cost of goods in going to purchase Azure subscription for the sole purpose of supporting the witness server, it does not bear out. It's not a good idea. It's not what we want you to do. But if you're already an Azure subscriber and you want to deploy a file server and an IaaS VM, you know, we're looking into that. We're trying to make that possible for you. All right. Now, hang on. I'm not quite done yet. I know I only have 3 seconds left, but there is just one more thing I did want to announce, and I'll just go ahead and bring this up now. And that is in CU2, the Enterprise Edition of Exchange 2013 will support 100 databases per server, up from 50 in CU1 and RTM. Excuse me, that was the big announcement? Yes, so to enable this, we made code changes, we removed blocking bugs, and we got all the folks to sign off and validate on it. Store, search, inference, managed availability, everybody. So in CU2, we are doubling the number of databases that you can support on Enterprise Edition. All right, so with that, oh, you like that? If you like that, you'll like this even better. All right. Okay, so with that, I am out of time, but I do want to take your questions, so I'm just going to pack up, and I'm going to head down to the office booth in the Tech Expo, and you can find me there. If not, feel free to ask me questions over email. Thank you for coming. Enjoy the show.